Welcome to this lesson. In this lesson, we are going to discuss arrays in Java. We're going to discuss arrays in Java. So let's go to our SRC again. Right click on our package and we go to new and we select new class. So the class name, we'll give it arrays. Say arrays. Right. Okay, so we have our new file. So let's have our main class. So we're going to say public static void main again. About public static void main, don't get worried, we'll talk about it later. You'll understand why I'm typing it, what it does and everything. So so that is our class, public static void main. Now let's talk about arrays. The first thing that we need to ask ourselves is, what is an array? What is an array? So basically, an array is a collection of like-typed variables that are referred by a common name. For example, if you have many books or many novels, you say you have an array of novels. So there are types of it's a collection of liked types that are under a common name. So we have specific elements in arrays being accessed by their index, and we have different types of arrays. We have one-dimensional and multi-dimensional. So let's talk about one-dimensional array. So don't get confused. We talk about an array, so we can say if we have a collection of integers, that is an array. We have a collection of Boolean values, that is an array. We have a collection of floating point values, that is floats, that is an array. So an array is basically a collection of variables of the same type, and they are normally referred by or referred using one name. So let's talk about one-dimensional array. So when we look at one-dimensional array is like a list, just like a list of items. So the format for putting a one-dimensional array is you need to specify the type, followed by the variable name, the type followed by the variable name, and then we have a square bracket. That is how we declare a one-dimensional array. We have a square bracket, then of course followed by the semicolon. All the statements in Java are ended using a semicolon. So if you look at the type is basically the data type of the array elements. For example, if you're creating an array of integers, then the type is going to be int. Then we have the variable name is the element, actually the name or the identifier that you give to your variables. For example, if you want to declare a variable to hold days, so you can say something like int days, and then we have the square brackets. So one square bracket indicates that it is a one-dimensional array. Two square brackets indicates that it is a two-dimensional array. Three square brackets indicates that it is a three-dimensional array. So the value of days, when we declare an array, for example in this array, the value of days is set to null. Okay, set to null, and if you want to link it up with some actual integers, then we must allocate one using we need to use the new keyword, and then we assign it to days.new. So that means first of all we declare the array, then we allocate values to the array. So it can be the general formula for, or the entire formula. I just showed you the declaration part. So the entire formula is this array. We need to have the array variable. If we want now to actually allocate values, we say the array variable, then we say is equal to new, then we indicate the type, and then in square brackets we can indicate the size of the array. The size of the array simply means the number of elements the array is going to hold. The number of elements the array is going to hold. So an example could be something like we say days is equal to new int, because the type is int. Days is equal to new int, then we have the square bracket. So if we are holding 7 days, then it will be 7. 7 is the size of the array. 7 is actually the size of array. So in general, to create an array, we need to declare a variable of the desired array type. Then we allocate memory to that is going to hold the array, now using the keyword. So all these two statements, int days and days is equal to new int, can be put into one statement. We say int days, where in this case now we are declaring a variable that is going to hold the desired array. That is step 1. Then we say int days is equal to, now we create a memory that is going to hold that array. So we say new is a keyword I'll discuss later. So we say new followed by the type new int, and then we assign it the value of 7. So when we say this, we have actually created an array. We've given the array the name days, and this array is of type is going to hold values of the type integer, and it is going to have 7 elements. So after creating arrays, we can access the elements of array by specifying the index of the arrays in the square brackets. For example, if we say something like this, you can say something like this: system.out.println. So we want to print the days at position 4. That's what we say. In other words, we are accessing the value of the array that is at position 4. Now it's important to understand that arrays are 0 based. They are 0 indexed based. In other words, when we are referring to the positions of the array, the array elements, we start from 0, 0, 1, 2, 3. We don't start from 1. Okay, we start from 0. So let's write an example program so that you get a better understanding of what is happening. So I want to actually to record the days in months, in a particular year. I want to record the days of months in a particular year. So we need to create an array that is going to be of type integer, and it is going to hold days in months. It's going to hold days in months, and this is an array. It is a one-dimensional array, so we have one square bracket. So we need to say is equal to new int, because the array contains integer elements. So new int, and then we want to store 12 months. Then we show the days for each month. So the array, the number of elements is going to be 5. Now we can store values in all these months. So I can say to do that, we say days in months, and then at the 0 position, that is at 0 position, at index is 0, we want to store 31. Then we're going to do the same thing. I'll just copy this because we want to do the same thing 12 times. I'm just gonna copy that, and then I will paste it here 12 times. So 1, 2, 3, that is 3, don't worry. 4, don't worry. 5, 6, 7, 8, 9, and 10. So let me remove this V here. It's useless there. Now, so we have the first position, which is 0. So the second position is going to be 1. The third position is going to be 2. The fourth position 3. Yeah, that is 4. Is going to be 5. Is going to be 6. It's going to be 7. This is going to be 8. This is going to be 9. And this is going to be 10. Probably we need one more, and this is going to be 11. I want you to notice something, that the position or the index of the last element is obtained by taking the length of the array, which is 12, then you subtract 1. So the last element has an index position of 11, and the reason is because we are starting counting from 0. So we can store the different months. So let's say January has 31. I'm not very sure about these days anyway. This one has 28, this one has 30. Let's say this other one maybe has 30. Let's say this other one has 31, 30, 31, 30, 31, 31. Let's say again this one has 30 and December has 31. Yeah, so we have first declared an array here, and then we have created a memory location for that array that is going to hold 12 values, and then we have stored values in the array using the bracket notation. We have accessed the array using the bracket notation, and we have stored 31 in the first position as the first element. Second element is 28, third element is 31, all the way to the 12th element, which is 31 as well. So we can actually access these values. We can access the elements of an array using by referencing the index of the array. You can access by referencing the index of the array. So let's come down here and let's try to print the number of days at the 4th position. So you can say system dot out dot print ln. We want to print the number of days. We say days in months, at position what? 4. Days in months at position 4. So I want you to check here that at position 4 we have 31. So we expect that 31 will be printed. So let's run our application. We run our application, then we come and check the output here. The output is showing what? The output is showing 31. So you can initialize also an array when you declare it by you can actually give its components when you declare it, instead of declaring the array as we've done then put in components. You can just initialize it during declaration. For example, we can let's just remove all this up to here. Yeah, so we can declare it and then give it values. For example, say int days in months, int days in months. So we use curly braces. I want you to get that. We use curly braces, and inside the curly braces we are going to put the elements. Inside the curly braces we are going to actually put the elements. So it's supposed to be days in months. Here we have the square bracket. Days in months, you have the square bracket, then we have an equal sign because we are actually initializing it. So then we can put the days in months in here. We say 30, 31, 31, 30, 31, 30, 31. How many are those? 1, 2, 3, 4, 5, 6, 7. They are 7. Yeah, we can add 3 more. 31, 30, 31, and again 31. So what we've done here, we have declared an array and we have initialized it, the array, with elements. So when you are initializing the arrays with elements, you need to use curly braces, and then you separate each element with a comma. So you see, if we print the fourth element, you can see this is element 1, element 2, element 3, element 4. If you print the 4th element, we should be able to see 30. So let's run this. If we run our program here, you see what is showing us, what is giving us. It's showing, okay, this is position 1, 2, 3, 4. we are printing fourth position. It's supposed to show us 30. This one is showing 31, the previous one. Let's see, did I really run this thing? I have zoomed the screen, so I don't know what's the issue. I'm running this. Okay, okay. Let me just right click here. Just right click and I say run as, let me run as Java application. There is there's a prompt that I should see that I'm not seeing. I don't know what is happening, so let me just zoom in that way. I need to see what's the issue so that I fix it. It's giving me 31. Wait, 1 2 3 4 system.out days in months, for let me change this one to something else. Let me change it to index 5. Let me see. Just want to see what's the issue. Yes, let me select that. Index 5 is so 1 2 3 4 5 0 1 2 3 4 5. Oh yeah, it's okay. Let's return 4. I was counting wrongly. Let me zoom in again. So when we run this, it's supposed to print the fifth value because it's in position 4. So it's supposed to print the fifth value. So let's check the fifth value from here. This is 1 2 3 4 5. Yeah, that's 1. Okay, that's okay. So that's how we can declare, we can initialize arrays that way. Now when we initialize arrays this way, enough space is created to hold the array elements. Thus we don't need the new keyword to actually create space. If you try to access elements that are outside the range of the array, or outside the length of the array, then you are going to get a runtime error. Now the reason is because the Java runtime system is going to check to ensure that values are not out of range. For instance, if I just come here and say I'm accessing, we have 11 elements, we have 12 elements, so the last element is in the position 12 minus 1, so the 11th position. So let me try to access the 13th element. You see, it is not showing an error right now, but if we run this program, it's gonna show an error. Let's just run the program. We run the program, it's gonna show us an error. Now you see exception in thread main. Says what Java lessons.array main index 13 is out of bounds for length 10. So it is out of bounds because the length of the array is 10. That means the length of array is 12. That means we cannot access beyond the length minus 1. That's my point. We cannot access beyond the length minus 1. That's why we're getting that error. So it's important to get that. Now if you just look at it this way, you might think array are not really useful. Let me show you just a simple use. Like we want to find the average of numbers. We supply numbers, then we get the average of all the numbers. So let's say int, and we say numbers, and this is a one-dimensional array. And let's say let's initialize a number of items for this particular array. Initialize a number of items for the particular array, and we give it something like 30, 32, 78, 90, 90, 45, and that's it. So just give it those values, and yeah, so we have initialized an array. So let us get the average. does get the average. So we need to get the results first. So we'll say int result. We are going to store the result of the average in the result variable, and then let's iterate through. So I'm going to say for, don't worry about iteration, I'm going to cover it later. So say for int I is equal to 0. Now this program is going to give us the average of all the values that we have supplied in the array. Even if we change and add more values or remove, it's still going to do the same thing. Then when I is less than or equal to, of course, numbers dot length, because we don't want to go out of range, so we want to make sure that results is less than or equal to numbers dot length. And again we need to, let's increment I. Okay, let's increment I. That's it. Let's increment I. So let's write the code here. We are iterating through our array. So as we iterate, we say result is equal to result plus 1 is equal to result, and we add 1 to result. Result is equal to result plus 1. What is happening here? Let me see what issue is there. Local variable result may not have been initialized. Okay, no problem, we can assign it to 0. No worry. Yeah, let's assign it to 0. Yeah, then let's continue now. So we want to have, actually we are not going to add 1 here, we want to add those numbers. So we want to add, the first one is 32, then we want to add, the first one is 30, we want to add 32 to 30. So we have to access the numbers with an index. So we're going to say numbers at the index, and in this case our index is I, so we add numbers at I. And then what we're going to do is we just print result. We'll just print result. So we say system dot out dot print ln. What we are printing here is result. So this is how this program is working now. First we are initializing our index to 0. So we check at index 0 here. That is the first iteration, index 0, and index 0 is less than numbers dot length. So then we take result, which is 30, which is 0 actually. Then we check the number, the value at index 0, we add it to result. So it will be 0 plus 30. Then it's stored in result. So the next iteration, result is 30. Then we say 32 add to 30. The next iteration results is 62. Then we go again until that circle ends. So let's run this program. So arrays are really useful, especially you are going to do a lot of iteration through arrays. So you can see what are we getting here? 6 is out of bounds. I think there's a statement that I did not change. Let me see. Oh yes. I understand what is happening. So it's okay. So every time we are actually printing, every time it goes around, we are printing this result. Now let's just see let's we are incrementing I. Result is equal to result plus numbers at I. We can also try to print result divided by 3. Yeah, you can print results divided by 3. Then we run this. When we run that, then we check our output here. So we are getting, the first one is 73, then 103, then 18. Okay, so so that's it with one-dimensional array. So we can go to we can talk about multi-dimensional array. So let me just multi-dimensional array. Let me create a new class. Let me create a new class. Go to new, then I say class, and I'm going to call it multi-dimensional. I'll call it multi-dimensional. Then let's add our main class. So public static void main have string args. So we have the square brackets, and we need to open the curly braces. So I have mentioned about multi-dimensional arrays. So multi-dimensional arrays are basically arrays of arrays, and each dimensional array it needs to be specified using an additional square bracket, something I've mentioned before. So if we are doing a two-dimensional array, we do something like int the array name, which is, let's say, just r. Then we are going to have two brackets. That means this is a two-dimensional array. So you can say equal to new int. You can say equal to new int, and then we specify. So this is a 2x4 array. A 2x4 array. So that's how we declare a two-dimensional array. So we specify two. If we want a three-dimensional array, we will add another square bracket here. Then this is the row column. So we have a 2x4 array. So these are two-dimensional dimensional array. It is a 2x4. It's like a matrix, 2x4 matrix. So it's like a matrix. Now, looking at this example that we have here, we can still iterate through a two-dimensional array. Don't worry, I'll get back to arrays in detail. So you can say int I, comma j. Let's also say k. We want to iterate through. We want to iterate through this array. So we can say for I is equal to 0, and I is less than 4. Okay. I is less than 4. Let's just change this one to 5 so that we can have this working. Well, I is less than 4. Then let's increment I. So the first loop is iterating through the outside array. Then we need to iterate through the inner array as well. So we can say we need to iterate the inner arrays as well. J is equal to 0. Then we say j is less than 5. J is less than 5. Let's increment j plus plus, and then we have our curly braces. So we can say we can call our array. Now we said r, so say r. So at I and also at j, we assign that to k. We store it in k, and then I want us to increment k. So just k plus plus. So let's okay. Let's initialize all these 3 to 0. All these 3. Let us initialize them to 0. Yes. Okay. So now we need to again have. You can have another iteration. Here we say I is equal to 0. I is less than 4. I plus plus. Then we have our curly braces, and in the curly braces we say for again j is equal to 0. j is less than 4, the j is less than 5, sorry, and then we increment j, and we have that. So in here I want us to print, let's say system.out.println. What we're gonna have there is our r at position I, at position I, at position j, at position I, at position j, and you can have some, you can have an empty, just have that there, okay, and then let's print just an empty line, say system.out.println, and what we have here is just an empty line. So arrays can really be useful. That's why I have spared a lesson, actually not one lesson, many lessons, to just discuss arrays. I'm just introducing to you how to declare arrays and everything, how we can declare arrays and everything. So we can iterate through arrays that way. So when we are allocating memory for a multi-dimensional array, all we need is to specify the memory for the first, that is the leftmost dimension. Then the remaining dimensions can actually be allocated separately. So we can allocate the remaining dimensions separately. Now, for example, if we look at this, okay, if we look at this example here, say int 2d for 2 dimension, int 2d, we just have 1, then we say this one is equal to new int, and then we supply it with 4 and another square bracket, let's give it 5. Yeah, let's not give that 5, we were going to allocate it later. So these are 2-dimensional arrays, so we need to add another square bracket here. Now what I'm trying to say, and I'm trying to show you, is that when you want to allocate memory for a multi-dimensional array, you can just allocate the left side, then you allocate the right part, the right part you can allocate it separately later. That's what I'm trying to say. So you have allocated the left part here with 4, but we have not allocated this other one because I want to allocate it later. So to allocate it, we can do this. You can say 2d at index 0. We say this one is equal to new. It's equal to new int at index 5. New int at index 5. So you see, we are storing this at this this index. So we are assigning the right side later. We're not assigning it right from declarations. So we can copy this. Just copy that to 7 times, and I'm going to paste it there the second time, the third time, so that this becomes now index 1, this becomes 2, this becomes 3. Then we can just this one will remain 5 5 5 5. Instead of putting 5 here, we'll just have it as 5 5 5 5. So we have allocated the left side first here, yes, and then we are allocating the right side later here. We are allocating the right side later. Now, the advantage of allocating dimensions manually is that you don't need to allocate the same number of elements for each dimension. So you can actually you can change the number of elements for each dimension. Like you see, this one is 5. If you allocate manually, you can actually change this to something like, let's say this can be 8. Yeah, this can be 4. Yeah, so when you allocate them manually, you have the freedom of changing the number of elements in all the dimensions, uh, in the various dimensions. Now, we are just introducing arrays, guys. Don't worry. If there's anything that you're not getting right, things will be clearer as we go on. Now, I want us to look at the last thing for this lesson. I call it the alternative array syntax. The alternative array syntax. So apart from declaring arrays the way we've been declaring, there's another way we can declare arrays. So I'm not going to create a new class. I'm just going to erase this. There's a new way of declaring, actually declaring arrays. That is what I call an alternative syntax. So this is the way you give the type. You give the type, then followed by the brackets, the square brackets, then followed by the variable name, then semicolon. Let me show you an example. You can say int maybe al is our name, then we have the square brackets, then we say is equal to new int, and we specify the value 3. Now this one is the traditional way that I have shown you first, but we can declare that same array in a different way, and we say int, then followed by the bracket. So in other words, we are saying the variable name comes later. The alternative syntax is that the variable name comes later. So you see, after the square bracket is now where we can have al. Yes, so you can have al, then we say is equal to new int, and we say 3. You see, all these two procedures are actually declaring the same array. That's why you see this error here, because we've declared the same variable, the same array twice. Duplicate local variable al, because this one is declaring the variable and this one is declaring the variable. So this is the alternative way of declaring arrays, and I'm gonna tell you why this is important. Let's remove the traditional way first, so that we are left with the new way, or the alternative way of actually declaring array. So this new way is actually more convenient when you are declaring several arrays at the same time. When you want to declare several arrays at the same time, it's actually convenient. For example, I want to declare 3 arrays. I want to declare 3 arrays that are going to be of type int. So I can simply say int, then I put that bracket. So I put the square bracket, then I can write maybe the names of the array. So nums1 is my first array, nums2 is my second array, nums3 is my third array. So you realize, and I can say all this equals to all these equal to, let me have int here again. You need to have nums2 and a square bracket. The square bracket must be there. So so have the square bracket. If you have the square bracket after the name, you can actually declare many arrays at the same time. So that way, then we can say is equal to new, then new int, and then supply whatever values we want to supply. So you see, this declaration, let's come to this declaration here. If you look at this declaration, it is actually creating 3 arrays. Yeah, this is creating 3 arrays, but I want to show you some magic. Let me even remove this. Let me show you declaring 3 arrays using now this new conversion, like this new way. We say int. Using the new way, we can simply say int, and then you have the square brackets, and then what follows later after the square brackets is actually the names. nums1, comma, nums2, comma, nums3. I just want you to see how convenient this is. So I have declared 3 arrays three arrays with different name, but they are all integer arrays in that simple way. So if I want to use the other way, the traditional way of declaring that array, I can still come here and say something like int nums1, and I have a bracket. Now I want you to see, this is the traditional way where the variable comes before the square bracket. So I need to come here and again say comma, then I say nums2, then another bracket, then I say comma, then I say nums3, another bracket. Now you can see this line is even much longer than the previous one. This is much longer than this one. So this alternative way is more convenient when you want to declare many arrays that are going to hold similar types at the same time. Now let me briefly talk about strings before I end this class. Let me briefly talk about strings. I'll come back with and talk about strings much later, but just introducing it because we might need to use strings. Now, you did not hear me mention strings earlier because not because string is not supported by Java, but because in Java a string is not a primitive type, or it's not a simple type, nor is it an array of characters. In Java we define a string as an object, and for us to have a full understanding of strings, then we can only cover strings after we have covered objects, or the objects related features that we will cover later in the course. But briefly talking about strings, a string is actually a type, it is a string type that declares string variables and can also declare an array of strings. So you can assign a string to another string. Just a brief look at strings, so that to allow you use strings in your programs before we even get to the dedicated lesson where we're going to talk about strings. So you can actually declare a string this way. You need to use the keyword string, with capital S, the keyword string, then followed by the name. And you can say this is hello world. So the contents of a string must be in quotation marks. The contents of a string must be in quotation marks. So see, we can print this. You can say system out.println, and we can print str. So if we run this program, it should print hello world. Running this program should print hello world. So that's simple how to use strings. I'll talk about strings because I said strings. This string is not a primitive type. It is basically we will understand it when we cover objects.